Good afternoon, mathletes. I hope that the quiz went well for you. Um, I did want to talk about the last two problems on the homework, just the wording of it. Um, Common difference has to do with what we're adding between each of these. Okay, so you should have picked, I think it was choice three was number three. And then the second one, you had to notice they weren't adding, they're multiplying by negative two, multiplying by negative two. So if they want the eighth term, by hand, I could just multiply by 2, negative 160, multiply by 2, positive 320, multiply by 2, negative 640. And that was just a preview of what we're going to be moving into now, which is going to look a lot different. It's going to seem a lot different, but you've done all of this. And as soon as we get over, some of the look of it, and you get comfortable with it, you should be fine. Okay, so we're going to be looking at something called a sequence. Okay, all the sequence is really it's a pattern. Patterns happen all over the place. This first word is arithmetic, but it looks like arithmetic. This is going to follow the same thing we did with linear, which was most of the first half of the year, and it'll resemble y equals mx plus b. Now, geometrics, what we're doing that's new. This is our exponential, and our general form for exponential was y equals a times b to the x. All right, so I want you to take a couple minutes, try and figure out what is the pattern. Are they multiplying? Are they adding? All right, so if I was like counting, there's 2 triangles, then 4, then 8, and then, if you can't draw it, that's fine, but what would come next? And then with the squares, same idea. There's 1 square, 3 squares, 5 squares, like how would that continue? So please pause the video, see if you can figure out which one is a multiplying geometric and which one is an adding arithmetic. Pause, figure it out. Hopefully you paused it. So following this pattern, I went from 2, it doubled to 4, it doubled to 8, it doubled to 16, and then I couldn't draw the 32, but hopefully you found that idea. So this is more of a geometric pattern, whereas here I went 1 square, I add 1 to the top and to the right. Okay, so I'm adding 2 each time, so eventually I get 7, then 9, and then 11. So if we're looking at these patterns, okay, we had 1 triangle, 3 triangles, 5 triangles, 7 triangles, 9 triangles. Okay, and if we were thinking about this, like y equals mx plus b, okay, but now they're going to use an n instead of an x. So my slope would be 2, because I'm adding that 2 every single time, okay, and my y-intercept, if I went backwards, so instead of adding 2, now I subtract 2, I would get minus 1. So they call this a rule, 2n minus 1. Just think of it just like we did when we were writing the equation of a line. Now, geometrically, we started out with 2, then 4, then 8, 16, then 32. Okay, so if it's geometric, we're thinking this follows more of this pattern. All right, so this times 2 is my base. That's that 2 to the n. All right, and if I went backwards to 0, like this way, I'm multiplying by 2. If I divided by 2, that would give me 1. So technically, there's a 1 in front of this. So you could do 1 times 2 to the n, but you do not need that. All right, so let's try to connect the two of those together. All right, I'm not going to have us graph them. I'm just going to go to the bottom of the next page, which I believe mine says, okay, can't move that. That's exciting. So this is the bottom of page 29. I just want you to take a minute, see if you can fill in the blanks, figure out, is this an adding pattern or is this a multiplying pattern? Okay, so the first two were adding patterns. Here I was adding 4 in between each terms. Here I was adding negative 2, or you can think of it as subtracting 2. Over here, you'll notice the difference between them is changing. Difference of 1, difference of 2, difference of 4. So then I try multiplying. This was multiplying by 2, and then this one was multiplying by a half. Try and get rid of the thought of dividing by 2 because we always want to know what we're multiplying by. Okay, and remember, in these videos, you can always pause. You can always go backwards. All right, we're just going to kind of jump around a little bit in the notes and make sure we hit all the big ideas for today. So I'm at the key concept box. All right, so a sequence has a specific name. This is definitely a function. We know what a function is. Every input has one output. Okay, domain is my input values. We used to use X a lot. Now my domain is going to use N, and our domain is only going to be the positive integers. So what that means is I'll have a first term, a second term, a third term, so on and so forth. There's no 0 term. There's no 1.5 term. Okay. We're going to have explicit formulas. These will be on the reference sheet for the Regents exam. Okay. But it's based on some term number. And this is going to show you, a little bit of what we've seen before. So I think you've seen function notation before, but the new one is this A with a little n. You pronounce it A sub n. It's called a subscript. And that little number is your term number. Okay. So if I had like f of 3, this would be the same thing as A3, and this is just asking you to find the third term. So once you get used to that, and you can connect it back to linear and exponential, we should be good to go. So this table is just kind of trying to show you, this is what it used to be when it was like X. So this part would be like if it was X, okay? Now these little numbers represent the X. So these little 1, 2, 3, 4, 5, 6 represent that term. We learned the function notation earlier in the year. So like f of 3 means plug it in for the third term. All right, so getting used to that notation can be a little bit tricky. Okay, but this is a typical problem. They'll say, here's the sequence. You have to figure out the pattern. All right, so I want you to figure out, are they adding? Are they multiplying? Okay, and then solve for A and B. Again, you're pausing the video. You're trying to figure out the common difference and then fill in the table. Thank you very much. Hopefully we're checking our work. So I notice they're adding 5 each time. So that's going to be my common difference. They use the variable D for common difference. All right. So in the chart, this used to be like X and Y. But now the little 1 represents the first term is 4. The second term is 9. Third term is 14. The fourth term is 19. My next term, if I added 5, would be 24. All right. So sometimes they ask you for, hey, what's the explicit formula or the rule? They're really asking us for the equation of this. And eventually we're going to get a reference sheet. When you get the Regents, you'll tear it out of the back of it. But on the reference sheet, it tells you this is our formula. So pause and write that down. And to explain what these are, this represents your first term. N is my input value. This used to be like our X, but that's my input value. Okay. And then D is my common difference. And D is very similar to the slope from y equals mx plus b. All right. So if I look back at my formula, A1 was 4 plus, and this n minus 1 is always the same. Okay. And then my common difference was 5. And I'm not a huge fan that it's at the end of it. Like you could still distribute the 5 into those parentheses. We're just not used to seeing those. Okay. So the purpose of this is if I wanted a little 12, that means I want the 12th term, and that means where the n is, I'm going to put a 12. Okay, and I want you to get used to, like, now you just type all of that in your calculator. All of that goes in there. 4 plus parenthesis 12 minus 1 close parenthesis times 5. And if I do the 12th term, that ends up giving me 59. So like your answer is 59. Okay, it could look like this. F of 12 equals 59, input output. A little 12 equals 59 is exactly the same thing. All right, so I want you to change this one to 74. This is the other way we're going to use the formula. All right, and there's more than one way to try and solve this, okay, but I'd like you to try and figure out how would I know what term is 74. So the two ways that I could think of doing this is you could still put it in your calculator, just put an X where the N is, and then look through the table. You're trying to find what X value gives me a Y value of 74. Another thought is a long way is just like keep adding 5 until you get to 74 and keep track of that. The other way I'd like to show you is with algebra. So if I use my explicit formula and I set it equal to 74, I would distribute that 5. I know that looks weird as it's at the end. Okay, and then I would add 5. And at the end, either way that I did it, I would find out that 74 is my 15th term. So I'm on page 33. I kind of want to put a summary together and just kind of give you a heads up of what we're looking at. So on the reference sheet, it's going to give us an arithmetic and geometric sequence. Here's the arithmetic one. Okay, and this follows a linear pattern. So it's like y equals mx plus b. They just use a's and n's sometimes. And then geometric, this is what it looks like on your reference sheet. And this follows an exponential pattern. Okay, and it looks very similar. Like A here was my initial value, A1 is my first value, B was called the base, or we sometimes called it the common ratio, and that's what R stands for. And then again, N is my input value, rather than having it be an X. Okay, so an arithmetic sequence is a linear function because it has a common difference or a constant rate of change, whereas a geometric sequence is exponential, and this has a common ratio, or you can think of it as it's increasing at an increasing rate or decreasing at a decreasing rate. Okay, the main thing we want you to pull from today is geometric is a pattern where there's multiplying, where arithmetic is an arithmetic adding problem. So the last thing that I want to do with you, and hopefully you'll do the homework after this, is this practice. And I want to go down here to B. So I want you to figure out, is this adding or multiplying? If it's adding, what's the common difference? If it's multiplying, what's the common ratio? Off you go. Really, try and figure it out. I believe in you. So I'm looking at it. I added 8 here from 2 to 10, and then I added 40. So it can't be adding. So I'm thinking, all right, 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. So that means it's geometric, and we're going to follow this pattern. Okay, so A1 is my first term, which is 2. My R value is what we're multiplying by, so this would be 5. All right, and that would be my answer if they want an explicit formula. If they wanted me to plug something in, I could plug it in further. Okay, but that's the big idea that I'm going for with this. I know this is going to be tough at first. Hopefully having this page will help with the two formulas from the reference sheet and how it's like linear and exponential. But we will meet again on Friday where we will finish up the unit. Next Tuesday, we plan to review, and next Thursday on Valentine's Day will be our test. I hope this video wasn't too painful, and good luck. Stock money out.